Hello everyone, I'm Dr. Samidhi Navaratna from the Department of Community Medicine. Today's lecture is Sampling and Sample Size Calculation. So, it is an important topic because you are supposed to complete a research project as a group activity for your CLR 5 exam that is going to be held in Y4S2, but you'll be starting it soon after your Y2S2. So it is important that you are competent in selecting a sample for your research and doing the sample size calculations. Okay, so let's start the lecture. So the learning outcomes for this session: by the end of this lecture, the student should be able to describe the non-probability and probability sampling methods, identify the most appropriate sampling method for a given research, then understand how to calculate sample size for different study designs in medical research. Moving on to sampling methods. A brief introduction to sampling. What is sampling? It is the procedure adopted to select a number of study units from a defined study population. And this sample should be adequately large to reduce errors due to chance. So as you know, a representative sample will have all the important characteristics of the population from which it is drawn. And the information gathered from such a sample can be generalized to the population from which it was drawn in the first place. The steps in the sampling process. First and foremost, you need to clearly define the target population. Then you need to select the sampling frame. And thirdly, you need to choose the appropriate sampling technique. Then determine the sample size and collect data. Then in the end, assess the response rate. Moving on to the sampling methods. There are two types of sampling methods. First one is probability sampling. The other one is non-probability sampling. So what is probability sampling? Let's see. Probability sampling involves random selection procedures to ensure that each unit of the sample is chosen on the basis of chance. Okay, and all units of the study population therefore has an equal or at least a known chance of being selected to the sample. So the aim of this type of sampling is to generalize the findings obtained from a sample to the general population. There are four basic types of probability sampling that you should know. The first one you should be aware of is simple random sampling. The next one is systematic random sampling. Third one is stratified random sampling. And the last one is cluster sampling. So let's look at each of these sampling methods in detail. Simple random sampling is a method of probability sampling in which every unit has an equal chance of being selected to the sample. So let's look at the steps. First, you need to make a numbered list of all the units in the population from which you want to draw a sample, and this is called a sampling frame. Then determine the desired sample size and then select the required number of sampling units using the lottery method, random tables or computer generated random numbers. So I think the lottery method is simple enough for you to understand. I'll discuss the random tables and the computer generated random numbers in brief in the next couple of slides. So let's use this example. Choose a sample of 5 students from your batch using the simple random sampling method. So as we discussed, either you can use the lottery method or use the random number table, or you can use some sort of an electronic random number generator to find these study units from your batch. Now, if you use the lottery method, it's easy. You can either write all the names of the students in your batch or their registration numbers and put it in a box, and then pick 5 students randomly, like in a lottery. You know, that is how you do pick numbers in a lottery. So similarly, we'll see how you can use the other types of methods. So the sampling frame is the registration list, right, where the students are registered. So either you can use one of these methods. So okay, so this is how a table of random numbers look. Just like in any other table, there are rows and columns, and each number consists of 5 digits. Now, for your purpose, you need to choose 5 students from your batch, and let's say your batch consists of 220 students, then you need to choose 5 numbers between 1 and 220. But these numbers consist of 5 digits. So, first thing you need to understand is that for your purpose, you are going to focus only on 3 digits out of the 5 digits. Okay, so let's say you are going to use the first 3 numbers of each 5-digit number. Now, from where to start? That also you need to predetermine in order to maintain the random nature of selection of these numbers. So, what you can do is you can pick a random number. Maybe you can place your finger, look in somewhere else, or close your eyes and then put your finger on the table to pick a random number. Or else, what I would suggest is you can use a pin. You can drop a pin on this table, and you can choose the number on which the pin head lies. Okay, then you need to predetermine from which direction you are going to move to select these numbers. You can either go down on along a column, or you can go along a row. So let's say I determine that I am going to go down a column, and I am going to use the first 3 digits of the numbers, and let's say when I put a pin on this table, the pin head was lying on 27569. So in that case, we are going to use this column. We are going to go down, and now 275 is above 220, so we can't choose, and 653 also we can't choose, so we are going to go down like this. Okay, we are going to go down like this, and the first number that will be suitable to pick is 119. So the next number is 119. Then again you will go down, then you have 76, and then you have 52. And now what to do? You are going to go up again and start from the top of the list, the next 3 digits. Okay, so the next column is like this. So you are going to pick 58, and you are going to pick 31. So you have chosen your 5 numbers. So please understand how to read a table of random numbers, and you can therefore choose any sample using this table of random numbers. Moving on to the random number generator. Actually, these days people don't use the random number tables anymore, because we have electronic random number generators, and if you just Google random number generator, you will come across many such random number generators, and it's very easy. You just need to put the minimum number and the maximum number, so and then just tap on generator, and this generator will actually pick numbers for you randomly. So you can generate any number between 1 and 220. So your sample size can be 5 or 10 or 20. So it will just generate. So it's very easy. So this is the most preferred method nowadays. What are the advantages and disadvantages of simple random sampling? Advantages are: requires minimal knowledge about the population in advance, and it's easy to analyze the data. So the disadvantages are: need a sampling frame. You need a full list of the sampling units of your target population. So it's not easy always to have such a sampling frame. So therefore it's a big issue if you are going to use simple random sampling to choose your sample. So it does not ensure that the characteristics of the sample and population will coincide exactly, because even though you are using a random method, there is, due to chance, there can be problems. So subgroups may not be included in appropriate proportions. So when you are picking randomly, there's a chance. Now if you want to study a particular characteristic in subgroups, say now you want to study maybe the prevalence of a disease among various ethnic groups. So if you are just using this simple random sampling method to choose your sample, there's no assurance that all the ethnic groups will be well represented in your, equally represented in your sample. So that's going to be a problem there. Moving on to the systematic random sampling. What is systematic random sampling? It is a method of probability sampling in which the first unit is selected at random and then the other units are chosen in a systematic way. Right? So that means in a regular interval. So how we are going to do that? Let's look at the steps. First, obtain a list of units that contain an acceptable frame of the target population. It does not have to be a full one like the simple random sampling. And then determine the desired sample size using the whatever the formulae that is acceptable for that kind of study design. And then determine the skip interval or the sampling interval, and then determine a random start point, and then beginning at the start point, select the units by choosing each unit that corresponds to the sampling interval. So what are the advantages and disadvantages of systematic random sampling? So the advantages are: it is less time consuming and easier than simple random sampling. And the sample will have an even spread over the population list and therefore will lead to greater precision. Then what are the disadvantages? Sample interval may coincide with the systematic variation in the sample frame. So if that happens, there will be a bias introduced, and selection of one sampling unit is dependent obviously is dependent on selection of the previous one. So that again can lead to some kind of bias if there's a systematic variation particularly. So let's use the same example. So you are going to now choose a sample of 5 students from your batch using the systematic random sampling method. So how we are going to do that? First you need to calculate the sampling fraction and the sampling interval. So the sampling fraction is 220 divided by 5. So this is the total number of students in your batch, and this is the required number in the sample. So the sampling interval will be 44. So the first step is to choose a random number between 1 and 44. Then select every 44th person from that number and continue the process till you have 5 students. Say you picked number 12 randomly, then the subsequent numbers will be 56, 100, 144 and 188. So therefore the numbers you will pick, the sample will consist of 12, 56, 100, 144, 188. So if you just compare these numbers with the numbers you picked from the simple random sampling, you will see that these numbers are actually evenly distributed in the population. So whereas in the simple random sampling you may get numbers in the maybe just from 1 to 100, between 100 they can fall, all 5 numbers can fall between 1 to 100. So but here in this systematic random sampling it's different. So they are evenly spread throughout this population. So that is one advantage, but there are disadvantages as we discussed. Moving on to the stratified random sampling, it is also a method of probability sampling in which the population is divided into different subgroups, also known as strata, according to some common characteristic, and a random or a systematic sample is then drawn from each strata. So let's look at the steps. First, you need to divide the target population into homogeneous subgroups or strata. Homogeneous means with the same similar characteristics, okay? Whatever the characteristic you are interested in. And then draw random samples of a predetermined size from each sample. Then combine the samples from each stratum into a single sample of the target population. So that is what you are going to do. Actually, this stratified random sampling, when you say you are going to take samples from subgroups or strata, it can be done in 2 different ways. That is, you can take proportionate samples from all the subgroups you are interested in, or you can take different samples. In proportionate stratified sampling, uniform sampling fraction or sampling ratios are used. Then the sample size of a stratum is proportional to the population size of the stratum. Then disproportionate stratified sampling is, you have differing sampling fractions and take a larger sample from the strata where there is more variability, thereby increasing the precision. Then permits heavier sampling from subgroups with smaller numbers. Sometimes you can, when there are only 3-4 people in one subgroup, you can take 1 or 2 from those subgroups as well to represent the population, because then it may not be proportionate to the number of study units in that stratum, but it will give you opportunity to study about these rare or the smaller numbers of individuals in the population. Then an appropriate weighting procedure is needed in analysis. Data from different strata should be analyzed separately. So what are the advantages and disadvantages of stratified random sampling? As we discussed, we can take relatively large samples from a small group using unequal sampling fractions. So that is an advantage. So what are the other advantages? Less sample variation than simple random sampling or systematic random sampling, and then the characteristic of each stratum can be estimated, and we can even compare between the strata. So what are the disadvantages then? We can only stratify by a known factor, right? So there can be many unknown factors within these groups, but only possible to stratify by a factor for which the population distribution is known and which is individually identifiable for every population member. If a stratified list is not available, it may be costly to make one. Then there can't be more strata than the number of sample units, and if many subgroups are there, it can be very time consuming and costly. Okay, so these are the disadvantages. So the same example, but the number of students I have increased to 6 because we are going to use 2 strata. Choose a sample of 6 students from your batch using stratified random sampling method. So how will we stratify your batch? 2 into maybe now I'm going to actually divide you into 2 subgroups, but you can use any other characteristic and divide your group into any other number of strata if you want to pick the sample that is appropriate for your study, for your purpose. But since it's very easy, I'm going to just, for an example, I'm going to divide into 2 strata, the males and the females, and I'm going to pick 3 from each stratum using simple random sampling method. So we have already discussed how we are going to use the simple random sampling method to your batch, but this time it's going to be 2 strata. That's the only difference. So we'll be picking 3 from each stratum. Okay, so 3 males and 3 females. Moving on to cluster sampling. First and foremost, you need to understand what a cluster is. So usually the clusters are geographic or organizational units. So for an example, for geographic units, you can take the provinces, the districts, the educational zones, maybe MOH areas, PHM areas, villages. So depending on the terrain. So it's the list goes on like this. So on the other hand, what are organizational units? For an example, you can take the classrooms of students, maybe the batches of medical students, then hospitals, then what else? Then the schools and even other banks and other organizations that exist in the community. So those are the clusters that I can think of, but there are many more. So having understood what a cluster is, let's move on to the definition. Cluster sampling is selection of groups of study units, which are also known as clusters, instead of individual study units. So we are taking groups of study units. So because of that, there's a problem that crops up That is, there's this thing called the clustering effect or the design effect. What is that? When cluster sampling is used, the effect of intra-cluster correlation must be taken into account, particularly when the sample size is calculated. Right? If we are using this cluster sampling method, then we have to make certain alterations to the sample size calculation. So what is this intra-cluster correlation? That is, that certain similarities exist within the clusters. Now for an example, take y'all. Y'all as medical students are different from the rest of your age group peers in the community. And within your batch or within the medical faculty, the students will be having certain similarities, right? Your knowledge in medicine or health related practices will be more than your peers, and maybe your behavior, maybe your attitude. So everything will be different from the rest of your peers in the community. So this is known as the intra-cluster correlation, and we have to take this into account when the sample size is calculated. So what are the advantages and disadvantages of cluster sampling? So a sampling frame for the individual units is not required for the whole population. So if you just have the sampling frames for the clusters, just the registers or whatever for the classrooms or whatever the batch you are using or whatever the cluster you are having, that is adequate. You don't need for the whole population. The selection of the sample is easier as the individual units are physically together as groups. So that is obvious. Because they are physically together in one place, it's easy to select the sample as well as to administer whatever the data collection tools you have or to carry out the interviews. So it's easy. You don't have to run here and there. You just need to go to few places where the clusters exist. So therefore it's administratively simpler, and in turn it's less expensive because of this reason. And additionally, characteristics of clusters as well as that of the whole population can be estimated. So then what are the disadvantages? There is a possibility that the final sample may not be representative of the total population. So there's just a chance. If the clusters contain similar persons, that is, as we discussed, if the intra-class correlation is very high, then it's difficult to estimate the precision with which the generalizations can be made to the parent population. So, because of that reason, we need to take a large sample to overcome this cluster effect or the so-called design effect. So, a similar example to understand the cluster sampling method. Choose a sample of 30 medical students from the Faculty of Medicine, University of Peradeniya using cluster sampling method. So, here you have been asked to choose 30 medical students, and there are 5 batches of medical students at a given time at the Faculty of Medicine, University of Peradeniya. And let's say we are going to consider one batch as one cluster. So there are 5 such clusters, and we will take an equal number of medical students from each batch. So we'll be taking 6 students from each batch. So that is what you have to understand. That is how you do the cluster sampling method. So when calculating the sample size, actually you just need to consider the number of this intra-class correlation, and then you have to take that into mind and multiply the sample size by 2 to overcome the clustering effect or the design effect. That you don't have to write it for this example, but just to keep that in mind. So moving on to multi-stage sampling. This is actually a mixture of sampling methods. So sampling done in 2 or more stages, carried out in phases, and therefore involves more than one sampling method. So what are the advantages? Construction of a sampling frame for each step is relatively easy and less costly. And then disadvantages are the less precise estimates. Yet another example to understand the multi-stage sampling. So say in a study to determine the prevalence of chronic renal disease, 300 houses are to be visited for data collection. The district is composed of 20 medical office of health areas, and each MOH area consists of 8 to 15 public health midwife areas. So this is one method of doing it, but there's no one correct answer. You can use any method that is correct. So this is a 4-stage sampling procedure I have described here. Select 10 MOH areas out of the 20 by simple random sampling method. Then from each MOH area selected, choose 3 public health midwife areas by simple random sampling. So then the total number of public health midwife areas would be 30. From each public health midwife area, select 10 houses by using the following sampling procedure. So go to the center of the public health midwife area. It doesn't have to be the exact center, but somewhere in the middle. Choose a direction in a random way. So go to a maybe a crossroad. Then you can spin a bottle on the ground and choose the direction or which road you are going to take, and walk in the selected direction and include every 3rd or 5th house you encounter till you get 10 houses. So if there are no occupants in the selected houses, then you can choose the next house. Then interview the required number of members from the selected houses. So that is what you are going to do here. So this can actually vary, the numbers and so on, but this is just to give you a rough idea what a multi-stage sampling is. A little bit about the probability proportion to size sampling. The clusters are chosen by a method that provides a self-weighted sample. So let's try to understand the sampling process of probability proportional to size sampling. The first step is to determine the number of clusters you are going to take for this study. And to do that, you have to figure out the feasibility initially. So that would be the human resources available and whatever the funds you are having for this study. So having done that, you need to calculate the sample size and then determine the number of study units you are going to take from each cluster. Okay, so say the calculated sample size is 3000, then if the number of clusters you are willing to select is 10, then you need to take 300 from each cluster. Having done that, the next step would be to make a complete list of all the clusters or blocks available in the population. So these would be called primary sampling units, and list them in one column, and then correspondingly in another column enter the cluster size, that is the original number of study units available in each cluster. So having done that, the next step would be to calculate the cumulative total. So in another column, you have to calculate the cumulative total. I hope you know how to calculate that. You need to add the number of study units in the first cluster to the second, and then that total need to be, you need to add the third cluster, the cluster size to the the two cluster sizes, the sum of the two cluster sizes, and so on and so forth. So then, having done that, you need to calculate the sampling interval by dividing the total cumulative population size by the number of clusters, and then choose a random number between 1 and the sampling interval and select the appropriate cluster by going through the cumulative totals. Now, if the calculated cumulative total is like 20,000, you need to divide it by 10 to find the sampling interval. Then it would be 2,000. Then you have to choose a random number between 1 and 2,000 and select the appropriate cluster by going through the cumulative totals. Say you got something like 938 or something. Then you choose the cluster that contain that number. Then, having done that, the next step is to select the rest of the clusters by adding the sampling interval to the randomly selected number, and so on. Then, from each of the selected clusters, same number of units should be selected to increase the precision. So this is what I have done. So now in this column you have the clusters, and in this column you have listed the size, the cluster size of each of these clusters. The first cluster has 1028 study units, the second one has 555, like that. So the cumulative sum is, you know, this in the first row it would be the same, then you add 1028 and 555, so it's 1583, and then to 1583 you need to add 390, then it becomes 1973. So to that you need to add 1309. So likewise you need to add like this. Okay, and then just focus on this, the F column, that is you are going to take 300 from each. Then the clusters that are going to be sampled, so you need to choose one number, random number between 1 and 2000. So say the number was 905, so the 905 would be in this, within the 1028, so that cluster you'll be taking. Then the next one would be, you need to add the sampling interval to this, that would be 2905. So 2905 will fall to this cluster, so you are going to take that. And then again another 2000, that would be 4905. So 4905 would fall in this cluster. So you see, that is how you will be choosing the clusters you want. So just go through this and see. So these are not very, you know, the weight and everything is not necessary for you at this moment. Just try to understand how you are going to choose the clusters according to the probability proportional to size. Moving on to non-probability sampling methods. Non-probability sampling methods do not use a random method to choose the study units. There is no equal chance of being selected to the study sample, and they are often used in qualitative studies, case series, and explanatory studies like pilot studies. So the types of non-probability sampling, there's convenience sampling and consecutive sampling, judgment or purposive sampling, quarter sampling, and snowball sampling. So we'll take these methods one by one and discuss a bit. So quarter sampling is a non-random sampling technique in which participants are chosen on the basis of predetermined characteristics so that the total sample will have the same distribution of characteristics as the wider population. The snowball sampling is a non-random sampling method that uses few cases to help encourage other cases to take part in the study, thereby increasing sample size. This approach is most applicable in small populations that are difficult to access due to their closed nature. So, for an example, now if you want to do a study, like say you want to do the prevalence of a sexually transmitted disease among the commercial sex workers, that is, the prostitutes and so on, the beach boys or whatever. So for that, now you can't go and sample them in any institution or in a community, because they will not disclose their identities. So how do you do that is, now if you can get hold of one or two people who are actually engaged in this kind of profession, then you can get their help to find the other people who are engaged in this profession. So you contact them and then you convince them about the importance of this study, and then get their cooperation to find other people. So you know how a snowball forms. So it starts from a small ball, and when it moves, it gets bigger and bigger. So likewise, now your sample will start with one or two people, and they will introduce you to a few others, and now you may have 5 or 6. Then you ask all 6 of them to introduce you to new people. So likewise, this sample will grow. So this would be very useful for samples that are hidden. So if you want to do a study among drug addicts or maybe school dropouts, then this would be very useful. Then convenience sampling is selecting participants because they are often readily and easily available. It is inexpensive and an easy option compared to other sampling techniques. You just pick those who are available. Convenience sampling often helps to overcome many of the limitations associated with research. For example, using friends or family as part of a sample is easier than targeting unknown individuals. So it's a easy way to do a research. Another type of non-probability sampling is the judgmental or the purposive sampling. In this type of sampling, the researcher will decide whether a person should be included in his study or not, depending on his personal subjective opinion. And consecutive sampling is considered as the best sampling method in this category. So every person who meets the inclusion criteria will be included in the sample. So it could be done over a period of time till a minimum number of people would be accumulated. So what are the advantages and disadvantages of non-probability sampling methods? Where quota sampling is considered, advantage is that the sample can be controlled for certain characteristics, but the disadvantages are selection bias and lack of assurance. So in convenience sampling, as the name itself implies, it's the most convenient and the least expensive and the least time consuming sampling method, but obviously there will be selection bias and the sample will not be representative of the parent population. Snowball sampling, we have already discussed that it's suitable for hidden populations and therefore it can estimate rare characteristics, and the disadvantage is the time consuming nature of the sampling. Then the judgmental sampling, it would be low cost, convenient, not time consuming, and it would be ideal for exploratory research designs, but the disadvantage is it does not allow generalization and can be it's very subjective. So consecutive sampling is the most the accepted method in this category. So the advantages actually include that it's very practical, and the disadvantage include duration may be too short to adequately represent the seasonal factors or other changes over time in the sample. Moving on to sample size calculation. So a small introduction to sample size calculation. The sample size is the number of patients or other investigated study units that will be included in a study for data collection. It is very important to determine the sample size according to the study design and the objectives of the study. So, sample size calculations are important in development of the study protocol. So when you give a proposal to the department, you will have to use this sample size calculations, and when applying for ethical clearance certificate and when getting the study published in a peer-reviewed journal. So at all these three stages, sample size calculation will be reviewed by another person, right? So, what are the factors taken into consideration when calculating a sample size? The first one is the outcomes variability or the underlying event rate. So, the underlying event rate is the prevalence of the variable under study. So, from where can we get this information? Either you will have to perform a pilot study, or you will have to search for similar previous studies that have been published. So you can use those prevalences as well. The variability in the outcome variable is the population variance of a given outcome that is estimated by the standard deviation. So the next factor is type 1 and type 2 errors. I do hope that you can remember these types of errors. Please go and revisit these areas if you cannot remember them clearly. And type 1 error is the rejection of a true null hypothesis, and type 2 error is the failure to reject a false null hypothesis. So the type 1 error is also known as a false positive, and the type 2 error is also called a false negative. So this type 1 error, if you can remember, corresponds to the level of confidence, whereas the type 2 error corresponds to the power of the statistical test. Third one is the effect size, that is the difference between estimation and unknown parameter which investigator wants to estimate. Usually we assume that the effect size is minimal. So how do we calculate the sample size for a cross-sectional study? As you know, a cross-sectional study is also known as a prevalence study. And the aim of a cross-sectional study is to estimate the prevalence of unknown parameters from the target population using a random sample. So it's important that we calculate an adequate sample size to estimate the population prevalence with a good precision. So if you don't get a large enough sample, we won't be able to calculate the prevalence with a good precision. On the other hand, if you take a bigger sample, then it won't be cost beneficial. So this is the equation we'll be using to calculate the sample size for a cross-sectional study. N equals Z squared into P into 1 minus P divided by D squared, where N is sample size, Z is statistic corresponding to the level of confidence, P is the expected prevalence, and the D is the precision. In calculating the sample size for a cross-sectional study, the level of confidence is usually aimed for 95%. However, researchers who want to be more confident can choose a 99% confidence interval. And as we just discussed, prevalence can be estimated from previous studies that have been published in the same study domain, or you can conduct a small pilot study to estimate the assumed prevalence. Then the precision should be selected according to the prevalence, and we don't have enough guidelines on this, but some authors recommend selecting a precision of 5% if the prevalence of the disease is assumed to be between 10% and 90%. However, if the assumed prevalence is too small, that is, if it is less than 10%, then take 1/4 or 1/5 of prevalence as the precision for these rare diseases. So, how do we calculate the sample size for case control studies? As you know, we use case control studies to find the risk factors that may be associated with the disease. How do we do that? We compare the risk factors in subjects who have the disease, that is the cases, with the subjects who do not have the disease, that is with the controls. So the information necessary to calculate the sample size include the assumed number of cases and controls who experienced the risk factors from similar studies or from a pilot study, and the level of confidence as well as the proposed power of the study. Now, in reality, we don't need to by heart the formulae to calculate the sample size calculation in this regard, because we have software and guidebooks for this, and we can use them. So if you are interested, you can get this book, the guidebook, from the internet. I think it's available freely. Lwanga and Lemeshaw's sample size calculation book, or there are electronic software also available in the internet. You can use them. So, similar to the case control studies, for this randomized control trials also, we don't need to by heart the equation, because we can use the formulae available on electronic resources, or we can use the Lwanga and Lemeshaw's booklet. However, the information needed to calculate the sample size for randomized control trials also include the power, the level of significance, the underlying event rate in the population, and the size of the treatment effect sought. So this brings us to the end of the lecture. So before I wind up the session, let me recap what we did today as a summary. So we learned about the probability sampling methods, and we learned about the non-probability sampling methods, and finally we learned about the sample size calculation for cross-sectional studies in particular, and we touched on certain other things, and you may need to read around the topics if you are interested to find out more. And that's about it. So please fill up the feedback form, and if you have any questions or queries, do not hesitate to get in touch with me, and please try to do the quiz as well. Thank you.